Hello and welcome to another ICMonitor tutorial. In today's tutorial, we'll talk about captured triggers and how you can use them to reduce the amount of captured data down to the data that you actually need. We'll talk about trigger settings by explaining the trigger configuration view. We'll show which scenarios can be realized by configuring triggers. And we'll give some examples with live captures and using triggers. Captured triggers are conditions that enable or disable further processing of telegrams during live or file capture. In other words, trigger conditions start or stop the actual capture. Conditions can pertain to types of telegrams, byte patterns, or certain data in telegram nodes. Capture triggers are very useful to reduce large amounts of data down to data that is actually relevant for you, or when hunting sporadically occurring errors, of which you know certain conditions where they might occur. Telegrams that do not meet the trigger conditions will then be discarded, and you can find the number of discarded telegrams down here. Once the trigger is active, capture will start as usual and stop again when the stop condition is met. We configure triggers in the Capture Trigger dialog, and we can configure start, stop, and a scope. So start condition and stop condition dictate when the trigger will activate and when it will deactivate the capture, and they contain telegram expressions. We can either type them in here if we know them. We can use the ICMP node as a very simple start condition. We can use our stored telegram expressions or create them using the telegram expression dialog. If the data around the occurrence of the trigger is relevant to us, we can activate a scope and define how much data before and after a trigger activation we actually want to have stored. We can do this in number of telegrams, in time, or data in kilobytes. We can also configure if trigger should be rearmed continuously and stay active, or if you only want to use them a fixed number of times. Depending on the configuration of your triggers, pre- and post-scope and activation patterns, we can achieve different activation behavior, which we'll like to show you with some illustrations. First, a little reminder about the capture process. The ICMonitor captures either telegrams live and buffers them, or directly from a file and starts processing. The first step of processing is checking capture triggers, and telegrams that do not meet it will then immediately be discarded. Once the trigger is active, processing can continue, and it can be stopped again when a stop condition is met. The most intuitive trigger scenario is depicted here, where we configure a start condition and a stop condition, and we'll set the activation to just one time. A user will then start telegram capture. The monitor will examine the incoming telegrams until the start condition is fulfilled. Activate capture. We'll get our capture until the stop condition is fulfilled, and the ICMonitor will then stop telegram capture. Now, if we're in the hunt for a reoccurring problem, we can set our trigger to activate either continuously or a fixed number of times. The behavior we get is depicted here. We have a start condition and a stop condition. We'll then manually start the telegram capture, and once ICMonitor detects the start condition, it will then start capturing and stop it with the fulfillment of the stop condition. Unlike in the previous scenario, capture will not stop though, but will continue until the start condition is met again, stop when the stop condition is met, and so on, either in perpetuity or your configured number of times. Another way to configure is just specifying a start condition. we'll again have to manually start the capture, and the capture process will then start once the start condition is fulfilled, and go on until the user stops Telegram capture manually. The other side is just specifying a stop condition, which will result in this behavior. We'll start our capture, which will also start capturing telegrams immediately, and will then stop automatically once our stop condition is fulfilled. Here we have a bit of a special case. We can configure a pre- and post-scope and just a start condition and let it fire once, and this will result in the following behavior. We'll start our capture. The IC monitor will monitor and cache telegrams. When the start condition is fulfilled, it will capture until it fulfills the specification for post-scope in time or data, or whatever you configured, and stop Telegram capture. So you have an implicit stop condition if you configure the IC monitor this way. The usual use case for pre- and post-scope is depicted here. We'll have our start and stop condition that work as explained earlier, with the difference of a pre- and post-scope being saved additionally to the captured telegrams. Now that we've learned about triggers and their configuration options, it is time to test it out with a live capture. Before the start of this tutorial, I cleared out the ARP cache on my machine. So in order to talk to any IP address that is yet unknown, we'll need an ARP lookup. We can test this behavior and observe it by using triggers. We'll set a start and stop condition, and I'll simply talk to an unknown IP using a ping command. So we'll set the start for the first occurrence of ICMP. Since we're only interested in ARP, we can stop observing once we see the first non-ICMP packet. Now, since the first packet will be ICMP and ARP happens before it, we would need a pre-scope. In this case, we'll set it to a number of telegrams. 2 would normally suffice since we have an ARP request and reply that we expect, but since there's a chance that some TCP packets might sneak in there, we'll set it to 5. And we'll see if we can catch a second ping in the post scope. That does it for our settings. Let's apply and start a live capture. Note that every time you start a live capture with active trigger or filter conditions, you'll be informed by this pop-up about active conditions and what they are. This is meant to prevent you from wondering why there's no packets showing up or fewer than you expect, when we might forget that we have conditions active after restarting the monitor. This behavior can be changed in the configuration options, which I'll show you after the analysis. Now we can see the number of telegrams or the number of discarded telegrams is increasing, but we don't see any telegrams being displayed. So let's go ahead and ping that unknown machine. And there we have it. The maximum number of activations has been reached, so capture has been stopped. And we can now observe what the monitor has captured for us. In red, we see the start trigger condition being fulfilled, which is an ICMP telegram as expected, and the stop condition is fulfilled on this packet. We have our pre-scope containing ARP as we expected, and we caught a second ping just barely in our post-scope. Now let's clear out the capture and trigger conditions and take a look how we can change this pop-up behavior. We'll go to Options, Capture, and we could check this Do Not Show Capture Settings info with the start of capture, and this will prevent the pop-up from showing. The other capture options will be discussed in a separate video, as some of them just need a little bit of explanation. In the beginning of this video I talked about triggers being applied to live and file capture, so let's test them out on a file as well. Go back to capture and configure trigger conditions. Now the file I'm about to load contains the trace from our analysis tutorial, so we'll try to catch this using trigger conditions. We need a start and stop condition, and we know about traceroute that it manipulates the IP's TTL field to achieve its result. Since I don't know that by heart, we'll use the Telegram expression dialog to create our expression. We'll go to IP header, TTL, and we know the first packet must have a TTL value of 1, so we'll use that as an expression. Now to stop, we'll go again to our expression dialog and formulate another condition that TTL should be bigger than 25. As we know, our target was reached in 10 steps. This should be just fine. Now any packet that is not the ping command and has a TTL bigger than 25 will stop. So we'll also concatenate the condition that it has to be ICMP. Now let's apply these settings and try them out. We'll have a file, load capture file, and load the trace. And there we see we have an active capture, and right after we have reached our maximum number of activations. So let's filter for ICMP and see if we got what we wanted. That doesn't look like the complete trace at all, so let's see what happened. We captured the first ICMP with a TTL of 1, but it doesn't say it's our start condition. So let's remove the display filter and see what our start condition caught. And we see here, it's a UDP protocol that has a TTL of 1 as well. So we need to change our start condition. How about the stop? Well, the stop seems to have caught an ICMP telegram just fine. But it's just another expired in transit, so that's also not what we want. So let's go back to our trigger and say we not only want a TTL of 1, we also want it to be ICMP. And in here, ICMP was not enough. So let's remove this part and see if we can be a little bit more specific. We'll go to ICMP. We want the echo reply to be present and have an identifier of 1. So let's apply the settings, and to use the trigger and filter that we just changed, we'll simply reload the capture. Now let's see if this looks better. And indeed, we seem to have caught the entire conversation by now. We have the replies down here, and we have the start of the traceroute up here. So when hunting for a specific sequence of telegrams, you can always adjust your triggers or filters and simply reload your capture. This also works if you have a live capture, as the IC monitor will just load it from a TMP file. That concludes today's tutorial. Thank you so much for watching, and we'll see each other in the next tutorial.